If your students are like ours, they probably have questions for you about the programming projects they're assigned. Not only questions about how to do things, but also questions about the intended behavior of their programs. No matter how thorough and clear we tried to make our assignment specifications, questions about program behavior invariably arose. So, starting in 2018, we gave students access to an automated TA which could answer some of these questions. Examplar. Examplar is an IDE for testing that can answer yes or no questions about the input-output behavior of functions. Let's say you're asked to implement a predicate, isPalindrome, that consumes a string and is satisfied when that string reads the same way forwards and backwards after adjusting for syntactic differences like punctuation. But you're unsure whether you should normalize for capitalization. Let's hypothesize no and write a test case. isPalindrome radar is false, where the first R is capitalized. When we click Run, Examplar will tell us whether our test cases are valid and thorough. If our tests are valid, which is the metric that matters most for this talk, it means they are consistent with the spec and will accept any correct implementation of the assignment. The fact that our test is invalid implies that isPalindrome ought to be case insensitive, which we can verify by fixing our test case and hitting Run again. Now, it's valid. We first deployed Examplar in 2018 to an accelerated Introduction to Computer Science course at Brown University. Since then, we've evaluated how this sort of tool affects final submission quality, evaluated how students balanced example writing with implementation throughout their development process, and for this work we asked, given access to such a tool, what questions do students still have about the input-output behavior of assignments? But first, let me tell you a bit about the course. The fall 2020 iteration of the course was entirely online due to the pandemic and enrolled 114 students, many more than in previous years. A quirk of Brown University's pandemic response allowed incoming first-year students to try their hand at this intro essentially risk-free. If they fared poorly, they could merely take the usual intro sequence, which was delayed until the following spring. For these incoming students, the accelerated intro was also the only course they took that fall. These unusual circumstances attracted nearly twice as many students than in previous years. The course featured 14 programming projects, and Examplar's validity feedback was available for all but 3 of them: Sorticle, Data Scripting, and Oracle. For all projects, students could seek help in 2 places, either synchronously in virtual office hours, or asynchronously on the class's online forum where TAs answered student questions. To discover what sorts of questions students had despite Examplar on these assignments, we looked at what they wrote on the forum, CampusWire. In the span of 13 weeks, students made a whopping 1,600 posts to this forum, which was 50% more than in 2019, even after accounting for the increase in class size. Of these 1,600 posts, about 1,250 concerned assignments, most of which related to topics like efficiency requirements, grading policies, partner selection, style requirements, and error messages. We expected a lot of questions about these topics because they're not questions Examplar even attempts to answer. Examplar only answers questions about the input-output behavior of functions. So, did it? Well, not entirely. There were still 298 questions concerning the input-output behavior of problems. This volume of questions suggests that Examplar might not be living up to our hopes. But why? First, we encountered numerous cases where students posed questions that could have been answered by writing a test case, running it, and seeing whether it was valid or invalid, but where there was no indication that the student did so. For instance, on data scripting, one student asked if the empty string would be a palindrome. The phrasing of this question implies a test case that the student could have written in Examplar, but they didn't. Why? Well, for questions on this assignment, we can guess. Data scripting was one of the few assignments where Examplar wasn't available. It could have been, but preparing Examplar for this assignment fell through the cracks at the last minute. Consequently, Examplar did nothing to mitigate the 42 questions students ultimately asked about the input-output behavior of this assignment. But what about the assignments where Examplar was available? Even if we only considered the 11 assignments where there was validity feedback, students still posed 169 questions about input-output behavior. For instance, several students asked if the movement functions in the updater assignment needed to be chainable. Again, this implies a test case. Try chaining some movement functions and see what happens. One student even provided a test case and asked whether it was consistent with the problem specification. This is exactly what Examplar's validity feedback can tell them, so why didn't it? In this case, the instructor asked the student why they hadn't just run their test case, to which they replied they were still pen and papering out the problem and thus hadn't realized that validity feedback would be available. What caught my eye here was that the student assumed that validity feedback wouldn't be available. We provided Examplar on nearly every assignment, so where could this assumption have come from? Well, that might have been true from the top-down perspective of an instructor, but the perspective students had looked more like this. At Updater, the student has had as many assignments without validity feedback as they've had with it. So it was silly to presume that students would have internalized they had this tool available at this point in the course. Not only can't students use what isn't available, they also won't rely on what probably isn't available. Ultimately, the prevalence of these sorts of questions led the professor to make this tongue-in-cheek announcement that the course would now have an expert TA providing instantaneous and infallible answers 24/7. That TA's name, of course, being Examplar. And once that announcement was made, questions about the specified behavior of assignments completely vanished for the rest of the semester. If only. Of the 169 input-output questions posed by students on assignments where validity feedback was available, 105 of them actually mentioned the feedback. The existence of these questions suggests shortcomings or confusion about Examplar. While our paper discusses a number of pathologies we discovered from these posts, the remainder of this talk is going to focus in on our discovery that 70% of these questions centered on the unspecified behavior of these assignments. Unspecified behavior is everything the spec doesn't prescribe an exact answer to, and it falls into two basic categories: unspecified inputs and underspecified outputs. A function has unspecified inputs when its behavior on certain inputs isn't described by the assignment. For instance, the median of an empty list is mathematically often undefined. A function has underspecified outputs when the assignment permits more than one valid output for a particular input. For instance, unless a sorting function is specified to be stable, the order in which it outputs equal elements is unspecified. Given this input list of two people who have the same age, it's perfectly valid for one implementation of sort by age to output Bob before Eve, while another might output Eve before Bob. If you're an instructor auto-grading student implementations, both of these tests are invalid and shouldn't be part of your test suite. If you didn't tell students that their sort by age implementations had to be stable, your test shouldn't assume stability. That would be inconsistent with the assignment specification. What you should do instead, however, is nuanced. If an input is unspecified, you shouldn't be writing tests involving that input at all. And if an output is underspecified, you need to write property-based tests instead. To write a property-based test for sort by age, we would first write a predicate, is correct, that embodies what it means for sort by age to be correct. Namely, that the output of sort by age should contain all the same elements as its input, and that the output should be ordered. You then write your test cases in terms of this predicate, rather than checking that the outputs are exactly equal to some expected values. Unfortunately, this nuance isn't only for instructors. When you place students in the position of tester, they too need to know how to navigate unspecified behavior. Fortunately, Examplar warns students when they write invalid tests, and the course dedicates 2 special projects solely to the concept of property-based testing, Sorticle and Oracle. From past work we've done, we know that students do fairly well with property-based testing on these particular assignments. But the questions posed by students on CampusWire suggest that many of them struggle to transfer these techniques to later assignments. Let's look at some of the patterns we saw on one of these assignments, TweeSearch. On this assignment, students implemented a fuzzy search function that produces a list of outputs in descending order of relevance. For instance, if you search for moo in a haystack consisting of foo and bar, this function should output foo, then bar, because foo is closer to moo than bar is. However, this assignment has unspecified behavior. If you're searching for moo in a haystack consisting of foo and boo, which are equally relevant, it's valid to output foo before boo, or boo before foo. If you write a test expecting exactly one of these outputs, Examplar will tell you it's invalid. Then, we hoped, students would apply the lessons of Sorticle and write a property-based test. Instead, many assumed something was deeply wrong, like this student who wrote, "I think there's something broken. The following checks all fail," which is interesting because they seem to cover every single possible output. What happened here is roughly that the student first wrote an exact value test asserting that the output was foo, then boo, which they then ran, only to discover the test was invalid. This student then realized that sorting boo before foo might also be a valid output. But rather than write a property-based test, they simply added that as a test case too, hit run, and found out they now had 2 invalid tests of every single possible output ordering. This story ends with them asking TAs if Examplar was broken, but other students reached more worrying conclusions. Like this student, who asked if Examplar's warnings of invalidity on these kinds of tests implied that it was invalid to write any test case where the search term had equally relevant results. In which case, rather than rewrite these assertions to use property-based testing, the right course of action would be to delete them. This is the very last habit we'd want to reinforce. Not only could this imagined constraint on the domain of search affect the correctness of the student's implementation, but it's guided them towards deleting perfectly valid tests. These observations are just the tip of the iceberg. We present many more in our short paper. Although this talk is seemingly ending on a grim note, we're actually really pleased with the role Examplar's feedback played in generating student questions. Although the class has been grading students on the validity of their final test suites for years, it wasn't until Examplar that students became confronted with their misconceptions during assignments, rather than only once they got their final grades back. In all, these observations are an opportunity for us to improve the course, assignments, Examplar, and even the programming language that students used. And they're an opportunity for the community to reflect on whether their classes might have the same vulnerabilities, yet undetected. Thanks for coming to my talk.